Good morning everyone, how's it going today? Welcome to this new video tutorial in which I'm going to show you how to set up a Python development environment and also virtual environments for your projects. This is some sort of a different video from the other ones in this playlist, but this is a very important one because I realized that it's not very obvious how to set up your development environment, install the right version of Python, or switch between versions of Python for different projects. So this video is going to set you up to actually follow through all of the tutorials in this playlist and to actually pretty much develop any project in Python that you want, okay? To do that, we're going to be going through this article that I wrote and I published on my website. The link is going to be in the description if you want to copy the snippets right here, okay? So without any further ado, I hope you enjoy it and let's go. Alright, so the first thing that we're going to be doing is we're going to install a package manager for our Mac, okay? If you are running Windows, you can use winget, which is very good as well. And if you're running Linux, you already have apt-get, so you don't really need this. This is for Mac. If you have any experience with Linux, you know how easy and convenient it is to have apt-get. It allows you to install your software with a single command and then upgrade it whenever you need it, and then just uninstall it as well with a single command. We don't have that in Mac by default, and that's exactly what we're trying to achieve by installing Homebrew. Actually, it will make your life easier, it's just going to make you much more productive. You can think of it as a app store for Mac, but it's not regulated by Apple. It's kind of a place where, it's kind of a repository where many software developers upload their software, and then you can just fetch it with a single command and install it in your computer and get it working right away. It is 1,000 times better than downloading applications from the internet and installing them manually. It makes maintenance and just management way faster and easier. And actually sometimes, especially for software development applications, it will be the only way to install these applications, okay? So right here, just in this tutorial, we're going to be using it to install several of our applications, all right? So how do we install Homebrew? To install Homebrew, you can open your terminal. So let's go right here. We open your terminal and we have to copy this command right here, or if you don't trust third-party blog posts like mine, you can go to the official website from Homebrew, brew.sh, and then copy this command right here and then paste it on your terminal and then click enter. I am not going to do it because I already have Brew installed. But once you have done this, you can verify that Homebrew was correctly installed by running brew -- version like this. There you go. If you see something like this, that means that you have Homebrew installed and that everything is working smoothly. Okay, good. So now that you have Homebrew installed, let's start using it to install other parts of our setup. Alright, so now that you have Homebrew installed, it is time to install Python in our system. Okay, this is going to be the system version of Python, or we might also call it the system Python, okay? If you're in a Mac, you already have Python installed. You can check that by going to your terminal and typing python -- version like this. There you go, and you will see your Python version. However, you see right here that I have Python version 3.10. If you have never installed Python manually before, in a Mac you might see that you have Python 2.7. That is because that is the Python version, that is the version that comes by default with Mac. But the problem is that not only is Python 2.7 an old version of Python, it is also a version that is not supported anymore by the official guys from Python, okay? So what we're going to do is we're going to be installing the newest version of Python. In order to do that in a Mac, we're going to be using our very fancy package manager that we just installed before. And in order to do that, it's very simple. You just run the command brew install, and then you say which package you want to install. In my case, it is Python. This works, if this sounds familiar to pip or npm, it's because it's exactly that. It's a package manager, but instead of it being for Python or for Node, it is for your Mac. It's very, very convenient. And then you're going to click enter. There you go. That was super fast because I already had it installed. It might take a little bit longer for you, but as you can see, it is running the latest version of Python now. Now, if you do Python -- version again, you will see that you have the latest version of Python. If you're running Windows, you may want to use winget to install it by running something like this. Or you can just download it from the official website. It's very straightforward. So there you go. That's how you install Python. However, something very, very important that I wanted to make clear is that, as I mentioned, this is the system Python. Okay? Now, what does that mean? This means that we are not going to be using it for development. The system Python is a version of Python that is used by other software when they require Python. Okay? So if you download an application that requires Python to be executed, it is going to run your system version of Python. However, and I really cannot stress this enough, you should never use your system version of Python for development. If you have heard or have had any headaches when developing in Python, or you know that installing dependencies sometimes doesn't work, or then you need another version of Python or whatever, most of the time, all of those problems come from the fact that people are using the system version of Python. Okay, so in order to just get away with not having all of these troubles, we're going to be using something that is called a Python version manager. This is going to allow you to install different versions of Python and to run them without having to mess up your system Python. This is very important. Okay, so let's do that now. Great, so now that we have our system version of Python installed, it is time to install a Python version manager. Okay, it's pretty good that we have Python 3 and all, but why do we need a Python version manager? Well, and the TLDR for this is this: to bring you calm and serenity in your life. Okay, in other words, to remove most of our headaches. In my experience, most of the headaches that come from developing in Python come from version management and dependency management. For example, how often has it happened to you that you're trying to run your code and it just doesn't work? It's not recognizing your dependencies. It might be because of your Python version is not working with some of them. And that's very, very common. Actually, in a previous video, we were working with a dependency that required Python 3.8 to work. And it was very easy for me to downgrade to Python 3.8 because I am running a Python version manager. But I saw in the comments that many of you guys were having trouble doing that. And actually, it sounds very intuitive to think that, all right, I am just going to delete or uninstall my current version of Python, right? And I'm going to install the version of Python that I need for this development. So you uninstall your previous version of Python and you install Python 3.8. All right, good. So now what happens with the dependencies that you had installed in the other version of Python? Are they going to work with this other Python? Well, probably not. And that's just going to break all of your development for a long time, and you're going to spend hours trying to solve that. That is one of the reasons why you should never use the system version of Python for development. So in short, having a Python version manager will allow you to install multiple versions of Python in your system. You will be able to switch between them very, very easily. You will be able to create virtual environments with a specific version of Python for each project. And it'll also allow you to install the packages directly in the virtual environment with the version of Python that they require. Okay, so everything will be bundled together, as we will do in just a few minutes. And then it also allows you not to use the sudo command, because sometimes you may want to do, if you want to install something, if you're running the system version of Python, you will have to do sudo install, sudo pip install, and that's very, very much not recommended. So yeah, it'll just allow you not to worry about messing up your system, your projects, and your dependencies, and to focus on what is important, which is developing your application. Okay. So there you go. Now, how do we install a Python version manager? All right. So now that you know why you need a Python version manager, let's see how to install it. Okay. And it's actually very straightforward. I like to think of a Python version manager as some sort of Austin Stevens. It can be like some sort of your snake master, or the one that's going to take care of all of your snakes or your Pythons. It will feed them, clean them, and make sure that they are healthy. Okay, this is exactly what a Python version manager does, but with your Python versions. For this tutorial, we're going to be using Pyenv. It's just the most convenient and simplest way to deal with Python versions. And here's the official repository. And if you want to install it, here are the official installation instructions for every operative system. Okay, I am in Mac, so I'm going to click here. And as you can see, you have to install it using Brew. Okay. Well, that's good news because we already have Brew installed. So we copy this right here, we come to our terminal and we paste that command right there. We click on enter, and that is going to install Brew in our, install Pyenv in our system. I already have it installed, so that was pretty fast, but if you haven't installed it, it's probably going to take a few minutes. And then in order to verify that you have Pyenv installed, you just do pyenv --version. And if you see Pyenv followed by your current version, it might be different for this one depending on when you installed it. That means that you have Pyenv correctly and successfully installed in your computer, and you can actually start installing as many different Python versions as you want. Okay. I must really stress this. It doesn't matter if you only want to use one Python version in your development. It doesn't matter if you don't intend to change your Python version. It is always a good idea to pass through Pyenv to install Python, because that way you're not relying on your system version of Python. Because once you mess up your system version of Python, it can only bring you trouble. Okay, this way you will have several versions of Python, or only one if you want, and then you can do whatever you want with it because it's a virtual Python. You can just delete it and reinstall it, and then reinstall all the packages, and everything will be running smoothly. Okay, so just keep that in mind, to always use Pyenv version, the Pyenv Python. And now it's time to actually start installing our Python versions. Great, so now your Snake Master is working. In other words, you have Pyenv correctly installed in your system. We can now actually start installing multiple versions of Python, or only one, as you wish, using Pyenv. Okay, you will see how easy it is. All you have to do is do Pyenv install and then the version that you want to install. Now, how do you know which version you want? You're going to want to go to Python, the official Python website, and you click on downloads right here. Here you will see the latest versions that they have. And as you can see, 3.10 is currently the latest security version. Okay, 3.11 is already out, but it is in bug fix maintenance status, which means that it has bugs. Okay, so if you want to develop your application and work in a bugless environment, you probably want to install 3.10. If you want to test 3.11, you're just going to have to go with the bugs. And 3.12, well, it's in pre-release, so yeah. What you're going to do then is you're going to come right here and do Pyenv install 3.10, like that. Now I already have it installed, so it asks me if I want to reinstall it. I'm going to say no, because I already have it, but you can, to you it's going to take a few minutes probably while it downloads everything and it actually installs it. Okay, So that is how you install a different version. And if you want a lower version, you can just specify it like this. If you don't specify the prefix, right? Like if I do Python -- version, you will see that I have Python 3.8.11, which is the latest revision of Python, okay? So if you don't specify a prefix right here, it is just going to install the latest one, to the latest revision, okay? So if you say Pyenv install 3.10, it's just going to install the latest 3.10. In this case, it is 3.11, okay? Now, if you want to check which versions you have installed in your system, all you have to do is to Pyenv versions, like that. And this will list all the versions that you have installed in your system. And these are, as I mentioned before, virtual versions, okay? Environments that you can use, and you can delete them as you wish, all right? The only one that is not virtual is your system version right here. And you have an asterisk right here, depending on which version you have currently selected, okay? So if you just installed the latest version of Python, even if you just installed it, that one is not going to be selected just yet, okay? You're going to have to select it, and I'm going to show you how to do that in a moment. All right, very good. So now we have all the Python versions that we want installed. What we're going to want to do now is we're going to install a global version of Python, okay? Now, what does that mean? Basically, all that means is that it is the version of Python that is going to be run whenever you just do Python like this, okay? So if I do Python -- version, that is executing the global version of Python. In this case, it is 3.10, but to you, if you haven't changed it yet, it might still be 2.7, okay? So let's change that. Just before we do that, let me just show you how to see where your current version of Python is being executed from, okay? To do that, you just say which Python, and it'll tell you which version of Python it is, from where the command comes, okay? The binary that executes the command. In my case, it's coming in directly from Pyenv because I am running a Pyenv version. Right here, as you can see, I am running a virtual version, but to you, it might be user bin Python, which is the default location for the Python installation if you haven't selected a Pyenv version. So let's select a Pyenv version right now. In order to set any of your versions that you have previously installed, this is very important, you have to have previously installed a version in order to set it as a global version. You're going to have to do Pyenv global and then the version that you want. So let's do that. Here I have 3.10.11, but let's say that for now I want to set a global to 3.8. So I'm going to do Pyenv global 3.8. Now if I click enter, and if I run Pyenv versions again, you will see that my asterisk right here is now marking my version 3.8, and that is because now I am running Python 3.8, as you can see. All right, so there you go. That is how you do. That is how you select a version. I'm just going to go back to 3.10, but this means that any application anywhere in my computer that wants to run Python, it's going to run my global version, and this is how I select which version of Python I want this to run, okay? So yeah, that is how you do it. And by the way, just so you know, now once that you have done that, next time you do which Python, you're going to see that it comes from the Pyenv directory, okay? So there you go. Now let's take a look at how to create virtual environments, which is the real juice of this, okay? So let's do that. All right, great. So now we have our Pyenv configured. We have installed several versions of Python, and we know how to select each one of them, okay? Now it is time to create our virtual environments, okay? And this is actually the step where you're going to start next time that you want to create a new project, okay? Because you will already have all the previous things installed. And yeah, so bravo for getting this far, right? But first, before I show you how to create a virtual environment, I'm going to tell you why it is important to have a virtual environment, okay? Now, if you have ever started a project in Python, you realize that you have to install some dependencies, right? So naturally, you're going to run to your terminal and you're going to type pip install, and then you're going to install your package, okay? And I mean, that may look very easy and very good, okay? The problem is that that package is going to remain installed in your system, in your global version of Python, okay? Now, when you delete your project, that package is going to remain installed in your global version of Python, even if it's in a virtual version of Python that you installed with Pyenv. It's still going to be installed in the global version of Python. And what happens when you want to start a new project and that other project requires a dependency that has the same name, for example, that may run into conflicts? Or what happens if you're working on another project that requires a very specific version of one of your packages, okay? Well, that is not going to work either because you already have one version installed in your global environment, so you're going to have to downgrade, etc. It's just going to cause you headaches, okay? The right way to do this is to install a virtual environment that packages it all into the project, okay? So basically, that means that every time, once you create a virtual environment, every time you run pip install inside of your project, all the dependencies will be installed only inside that project, okay? And not in your global environment. That's very convenient, right? So that way, I mean, yeah, you will have to reinstall the dependencies whenever you need to run a project, but it also means that you're not polluting your global version, okay? Now, just to summarize, having a virtual environment allows you to install packages locally for a specific project. It allows you to install different versions of packages for different projects. It allows you to install packages that are not compatible with the version of Python that you're using globally. And it allows you to install packages without having to worry about conflicts and to bundle your application with the same version of Python that you selected, because remember that you can select any version of Python that you want to use in your project, and bundle it together with the dependencies. So everything will be in the same container, in the same box. That's why the image right here are little boxes. You can think of each little box as a project with all its dependencies inside of it and the Python version that it's using inside of it. So all you have to do is take the box, open it, and you're ready to go. That is the usage of a Python virtual environment, okay? So let's see how to create one. All right, so now we can start, but the first thing we have to do is to set the local version of Python that we're going to use in our project, okay? You can, of course, skip this step if you don't require a very specific version of Python. That doesn't mean that you're going to be using the global version, okay? But if you don't specify a local version of Python, your virtual environment will default to the current local version and will create a copy of your global version in a local virtual environment, okay? Unless you manually select another Python version. So let's show you how that works. I'm going to create a project as I would do if I was going to start a real world project. So I'm going to create a new directory in my desktop. I'm going to call it my project. Okay, and then I'm going to use it. I'm going to open it using Code, VSCode. So there you go. Now here's my new project. Just going to zoom in a little bit, and I'm going to open the terminal right here. There you go. So now I can, in order to set up the local version of Python that I want to use here, let's say I want to use Python version 3.8, okay? So if I do Python -- version, you can see that I am currently using Python 3.10. All right, so if I want to use Python 3.8 in this version, let's just check before that I have it correctly installed. So I do Pyenv versions. And you can see that I have Python 3.8 installed right here. So I am going to do Pyenv local, because I am not changing the global version of Python. I am only changing the version of Python that I'm going to be using inside of this project, which means inside of this directory, okay? And I'm going to set it to 3.8 like this. I click enter, and you can see a new file was generated with Python version right here, and it says 3.8 because it is the version that I specified right here. Now, if I do Python -- version, you will see that I'm running Python 3.8 now, okay? But if I go to another directory, like my home directory right here, I am not inside the project. And if I do Python -- version, you will see that here I am running Python 3.10, but inside my project I am running Python 3.8. That is very, very convenient, okay? So that is how you set up your local version of Python. And if you want to see where that Python is coming from, you can always do which Python, and you will see that it is coming from Pyenv. But that is not what we want yet. We want it to come from inside our project. Now we told our project that we were going to be using Python 3.8, but we wanted to use the Python from inside the virtual environment. Let me show you how to do that. Great, so now that we have our local version of Python already configured, we can actually start creating our virtual environment, okay? And it is very, very simple. So what we're going to be doing is we're going to be running this command right here. It's python -m venv and then the name of your virtual environment, okay? So let's do that. Python -m venv and then the name of your virtual environment. Myself, I usually name my virtual environment just venv because whatever. But you can type whatever you want here. That helps you identify this virtual environment. I'm going to type this and then hit enter. And as you can see, a new folder called venv, because I named it venv, was created up here. Okay, so there you go. Now, once I activate it, you will see that every time I run pip or Python, it will be run from inside of here. However, not yet. If I do which Python right now, I am still running Python from Pyenv, okay? And I don't want that because that is my global version, okay? I want my Python to come from inside of here, and I want pip to install my things inside of here as well, okay? How do we do that? All right, let me show you that in a moment. Great, so now we have our virtual environment created, as you can see right here. However, it's not activated yet. What does that mean? So far, it is just a single folder inside of our project, okay? It's not doing anything yet. What we want to do is that every time we type Python, it's going to come from here. And every time we type, this is more importantly, every time we type pip install, we want it to install the things inside of here and not in our global version of Python, okay? So how do we change that? In order to change that, you can do source, and then you're going to execute this file right here, activate, okay? So we're going to do source venv, which is the name of my virtual environment. But if you named it differently, you will have to write the name of your virtual environment right here. Then you go to bin and then activate, okay? You click enter, and now you will see the name of your virtual environment right here. That means that your virtual environment is activated. And now, as you can see, if I do Python -- version, we're running Python 3.8 as before. But when I do which Python, you will see that it's actually coming from inside my virtual environment, okay? So the binary of Python is actually inside of here, and also the binary of pip. This means that it is going to be that whenever I run pip or Python inside of this project, when my virtual environment is activated, it is going to install all the dependencies inside of here, and that is not going to pollute my global version of Python, okay? So there you go. Important thing, if you are running Windows, if I am not mistaken, instead of activating it like this, you do exactly the same thing, but without the command source, okay? There you go. And then at some point, if you want to deactivate this local environment, you say deactivate. And there you go. There you go. And now we are back to our Python from Pyenv, okay? So there you go. That was how to enable and to activate your virtual environment. Great. So now the next thing we're going to do is we're going to be using Git, okay? If you are developing software, an actual application, it is a very good idea that you work with Git. Git is basically a source control mechanism that allows you to roll back to previous versions of your code, and it also allows you to store your code in a repository in a very, very organized manner and to work in groups, etc. But Git is a topic for an entire course in itself. I'm just going to show you the basics of how to set it up, okay? If you want more information about how to use Git, you can read this article right here, learn the basics of Git in 10 minutes, and it's very, very straightforward, okay? So if you don't have it installed, just as usual, remember, you can always do everything with Git with brew. Everything you can imagine, absolutely. So what we're going to do is, if you're not sure, you can always do Homebrew, install, and then you check if Git is available. Let's say, apparently Git is available for Homebrew, so you just do brew install Git. There you go. So that's what I'm going to do right here. I'm going to do brew install Git, and this one is actually probably going to take a while because I haven't upgraded it in a while, and for you it's probably going to take a while as well if you haven't installed it yet. So while that happens, we're going to come right here and we're going to come to our project and we're going to initialize a Git repository. To do that, we do git init like that, and that is going to start a new Git repository, okay? And that is going to start tracking all of our files. However, some files we don't want them to be tracked, okay? So, we of course want to know which Python version we're using, but we don't want to track the virtual environment because we don't want to track all of the packages in our code. We just want to know which packages are in our code. So the way to do that is to create a new file called gitignore. Okay, so you're going to do touch.gitignore. It's important that you name it like this. And just in case you don't know, touch is a command in Mac that just creates files. So now I have created my gitignore, and basically every single thing that you write in here is going to be ignored by Git. Okay, so in order to fill it, I usually just go for a very generic gitignore. So I do gitignore for Python. It depends on the technology that I'm using, but for Python, I just click here. And this is a very generic gitignore. It contains all of the usual things that you wouldn't want to be tracked on your Git repository. And this is very important because you're going to, one of the main uses of Git is that it allows you to put your code up in GitHub, right? And GitHub is usually public. So if you have API keys or your virtual environment, for example, these are things that you probably don't want public. So this right here, as you can see by default, it just removes the virtual environment default name for the virtual environment right here. So now I am tracking these two files, but Pyenv is not being tracked and it's not going to be uploaded to GitHub. Okay, so that is how you initialize Git. And in order to add all of the other files, you're just going to do git add, and then you say dot to say everything in the current folder, and then you say git commit to commit your first to make the first commit, and then you do first commit, for example. Okay, if you don't know what just happened, don't worry, it's not super important if you're not developing software, but I do encourage you to read this very, very simple basics of Git in under 10 minutes, okay, to get you started with it. And there you go. Now, before going to the notebooks, I just wanted to show you something real quick about .env and API keys, okay? So let's do that. Great. So now what I want to show you is how to create this other file that you sometimes see in other videos that is called .env. Okay, so let's do that. I'm going to do touch.env, and as you can see, VSCode already recognizes that this is a special file, okay? And actually, whatever you put inside of this file is going to be kept secret, okay? Because by default in the git ignore, you can see that it's hiding the .env files, okay? So this one is not going to be uploaded to your GitHub repository. And this is the place where you put your API keys. So my API key, and then you say whatever is your API key right here. And then let's say the port in which you're going to be exposing your application, etc. Right? So that's going to be here. Now, if you want to be able to read it from your script, let's say that you have your script right here, main.py, and if you want to read it, you're going to need, another dependency, okay? This dependency is called python.env, and it basically allows you to read whatever is inside this file, okay? So in order to actually use it, we're going to first activate our virtual environment. And now everything I install is going to be installed by venv. So I'm going to do pip install. I'm going to say python.env like that. That is going to install python.env inside here. And now I can import, from .env. There you go. We're going to import .load.env. Now we can just execute this function right here. That is going to allow us to read anything that is here. So if I now do print, and I say, in order to read it, I'm going to have to import OS as well. So if I want to print os.getEnv, I'm going to get this variable right here called my API key. Let's say like this. I can say this comes from .env. Now if I save this and I run it, you will see this comes from .env, and you will see my API key that comes from here. And that is hidden from GitHub, okay? And from whenever I upload this code, this file is not going to come with this, okay? So that is very important. But, sometimes this is very important for your code to work, right? Because you will need your API key for your code to work, you will need your port for your code to work, and other important information. So if this is not being added to your repository, how do other developers know which variables to keep here? And actually, in order to know, to help other developers use your application, you have to to duplicate this file right here, and you rename it and call it .env example. And basically, this is exactly the same file, but without it's raining hot, but without the actual confidential information. So we save it, and as you can see, this one is going to be added to Git and then the new developers that come will only have to fill this one in and change its name to .dnv so that it can be read by your application like this. Okay, so there you go. That's how to hide important information from the public. And also something pretty important that you may know is that if you're uploading your application to a server, how does your server know what are the values of these variables? And actually servers have something called environment variables that you will be able to set when you deploy your application, and it basically is exactly the same file that you see right here, but in your server. But you can see that when you start deploying your applications. So there you go. That was how to use .dnv. So there you go. Now you actually have your entire software development in Python environment setup. Okay, so now this is something that you can already use to start developing your applications. However, something that I like to have on the side for basically just sketching and running very quick tests is a notebook. Okay, and this is where Jupyter Notebooks comes in. Jupyter Notebooks is basically, you probably already know that, but it's just a piece of software that allows you to execute individual pieces of code of Python and run them individually. And it's very easy to run tests on them. Okay, so it's way easier to run tests over there than to start testing on your script, and then you have to write a function, then you have to debug it, etc. It's just easier to do it like this. You can, of course, install Jupyter Notebooks like this. You go to Jupyter Notebooks and you download it, or you can install Anaconda, and it comes with Jupyter Notebooks. But what I like to do, instead of doing all of that, I like to use Colab. And that basically is just Jupyter Notebooks on the cloud for Google. Okay, so you can just Google Colab and you will get right here. You just need a Google account. Okay, and this basically works exactly like you would expect. It works like Python. You do Python hello world, and here it just executes it right away. And here you can just upload your files that you want. Just be careful, because whatever you upload here is going to be deleted once you refresh the session. This is basically just for sketching if you're developing a full stack application in Python. Okay, and yeah, if at some point you need to install something like you would in a terminal, right? So for example, right here you have your code right here, and you have your terminal where you do pip install things, right? If you want to do that right here, all you have to do is to add an expression, an exclamation mark right here, and whatever you put after this is going to be executed in a terminal level. Okay, so if you do pip install, I don't know, TensorFlow or whatever, it's going to install it in this notebook in the cloud. Okay, and that is just very convenient to work with, because you can also store it in your Google Drive, etc. And just to show you, if I do ls, it's going to display the current files in the current directory. And as you can see, in my current directory, I have sample data, and then you have sample data right here. Okay, so yeah, there you go. Remember to use Google Colab. Very convenient, very easy. And then this is how to set up your project. There you go. All right, great. So congratulations. You have successfully finished this video, and you have successfully created your own development environment in Python that is going to work very good with your projects. And just remember to always use a version of Python that comes from pip install. Do not break your head trying to run your development in the system version of Python. That's just going to make your life easier. If you enjoyed this video, please just give a like and subscribe to the channel if you would like to see more videos like this. And yeah, I hope that it was useful, and I will see you next time.